All right, everybody, welcome back. Let's take a look at finding tan theta in the triangle. Okay, so we know that tan is TOA in SOHCAHTOA, and that is opposite over adjacent, and our opposite is opposite the angle, which here is 15, and adjacent is 8. Okay, so then we have 15 over 8 would be our answer. Let's check that if that's right. That's great. Moving on to flashcard 16, state the Pythagorean identity and one rearrangement. The Pythagorean identity is sine squared plus cosine squared equals 1 for every angle. And this is just the Pythagorean theorem hiding on the unit circle. So the two legs are sine and cosine, and the hypotenuse is 1. Okay, take a look at that diagram to your right. Okay, so sine squared theta plus cosine squared theta equals 1. Then sine squared theta rearranged would just be 1 minus cosine squared theta. Okay? All right. So let's just try a couple of problems here. If sine theta is 3 over 5, okay, then cosine squared theta equals 1 minus 9 over 25. Okay, you can see where I got that, right? And that would be 16 over 25. Therefore, cosine theta would be plus or minus 4 over 5, because if you took the square root of these, then you would get plus or minus 4 over 5. Okay, we got it with this. So cosine theta, let's see, if it was 5 over 13, then we're looking for sine squared theta equals 1 minus 25 over 169. And that would give us 144 over 169. Then sine theta would equal plus or minus, take the square root, and that would be 12 over 13. Okay? Okay, and then how about if we had 45-degree angle, then the coordinates would be square root 2 over 2 squared plus square root over 2 squared. Okay, remember your cosine is the x and the sine is the y. Okay, equals half plus half equals 1. Okay? So again, just picture it. The legs are cosine and sine, hypotenuse 1 on the unit circle, and the identity is that triangle. Okay? So this is the Pythagorean theorem in disguise, okay, on the unit circle. And the legs are cosine theta and sine theta, and the hypotenuse is 1. Okay, and then dividing through by cosine squared theta or sine squared theta produces the two companion or companion identities with tangent, secant, cotangent, and cosecant. All right? Okay, now we are just defining the reciprocal functions of cosecant theta, secant theta, and cotangent theta. And remember that a trick here is that if there's a C here, then it needs to be S here, and then if there is an S here, then there should be a C here, and then cotangent is the reciprocal of tangent. Okay, so just something for you guys to remember, all right, or to help you remember. So each of the three remaining trig functions is the reciprocal of one of the main three. So we flip each of the main functions to get its reciprocal. So cosecant flips sine, secant flips cosine, and cotangent flips tangent. So then cosecant theta would be 1 over sine theta, and then secant theta would be 1 over cosine theta, and cotangent theta would be 1 over tangent theta. Okay, and then just a visual on your right, just so that you can see what it looks like. And let's try a few problems at the bottom here. So sine theta, let's say, is 1 over 2. Okay, then we would get cosecant theta equals 1 divided by 1 over 2, and that would give us 2. Very good. Okay, so cosecant theta, if it was 4 over 5, then we would take secant theta, okay, the reciprocal, and we would get 5 over 4. And tangent theta is 3 over 4. Then cotangent theta would be, yep, the reciprocal, 4 over 3. Okay, so the pairs mismatch on purpose. So cosecant goes with sine, secant goes with cosine. Okay, and then never two matching letters. That means like sine and secant. Okay, that doesn't go together. Okay, so the names are Latin geometry. Secant means to cut or cutting line. Okay, and the co-prefix means the complement. Okay, complement function. Okay, and they look redundant now, but they appear constantly in calculus, where derivatives and integrals take their simplest forms in these terms, so you need to know how to do that, okay? Calculus. All right, so let's practice. Simplify sine squared theta plus cosine squared theta. That would give us 1, all right? Okay, so if we were to sketch y equals sine x on the interval 0, closed intervals 0 and 2 pi, what would the key points be? Okay, so what we want to do is for the sine curve, okay, you want to start at 0, and then you would peak at pi over 2, and then you would return to 0, and then it would bottom out at 3 pi over 2, and then it would complete the cycle at 2 pi. So that is 1 period, okay? They would call that 1 period, okay? So the amplitude is 1, and the period 2 pi, and that passes through 0, 0, which is the origin, okay? So it starts at 0, sine 0 equals 0, and it peaks at pi over 2. Okay, so sine pi over 2 equals 1. Okay, so remember your unit circle. And then back to 0 at pi, bottoms out at 3 pi over 2. So sine 3 pi over 2 equals -1. Okay, again, just think of your unit circle. Okay, just kind of stretched out like this wave. Okay, so this sinusoid wave is arguably the most important curve in applied mathematics, okay? And you'll see this a lot in sound waves, tides, alternating currents, hours of daylight across the year, okay? Because anything traced by this steady circular motion projects to a sine wave, and we call this a sine wave, okay? Circular, okay, motion. Great. Okay, so now we want to sketch y equals cosine x on the interval, the closed intervals 0 and 2 pi. What are the key points? Okay, so you'll see that there are similarities to the sine curve or the sine wave, okay, but this is the complement of the sine curve. So it starts at the max of 1 and then crosses 0 at pi 2 and bottoms out at pi, and then returns to 1 at 2 pi. Okay, so crosses 0 at 3 pi over 2, and then returns to 1 at 2 pi. So the cosine curve is the same wave as sine, but starting at the top instead of the middle. Okay, so cosine x equals sine x plus pi over 2. Okay, and we start at the top. Cosine 0 equals 1. And 0 at pi over 2, that's cosine pi over 2, equals 0. And bottom at pi, that's cosine pi equals -1. Okay, so you can see the height here, and then you can see the length of the wave, okay, that is all on this interval from 0 to 2 pi. Are we good with that? Okay, so cosine is not a new shape. It is the sine curve left by a quarter turn, okay, and that single observation that we are making, cosine x equals sine x plus pi over 2, explains why the two graphs are identical, okay, in every property except their starting point. Okay, so for y equals a sine bx, it gives the amplitude and the period. So let's apply that to y equals 3 sine 2x, okay? Which one is your A and which one is your B? Now, A stretches the wave vertically, okay? It's your height. And B compresses it horizontally, stretches or compresses it horizontally. And A is how tall the wave is, B is how squished it is. Taller A, then faster wiggle with bigger B. Okay, so amplitude will be A and period will be 2 pi over B, okay, because we have this interval here. So y, if y equals 3 sine x, 3 sine 2x, then the amplitude would equal 3, and then the period would equal 2 pi over 2, okay, which gives us pi. All right, so let's try 5 sine x, then the amplitude would be 5, and the period would be 2 pi over 1, and that would just be 2 pi. And let's try another one here, y equals 2 sine, let's say 4x, then the amplitude would be 2, and the period would be 2 pi over 4 equals pi over 2. Okay, so in sound, these two numbers are what you hear. Amplitude is the loudness, and frequency, the reciprocal of period, is pitch. Okay, so doubling the B doubles the frequency, which in music raises the note exactly 1 octave. Okay?